Right, in this video we're going to test whether a observed lambda for a Poisson distribution. Right, Jose works at a call centre. He's supposed to receive 5 calls per hour. He complains he is overworked, so the next day it is monitored that he received 9 calls per hour. Test at the 5% level whether Jose's workload has significantly increased. Right, let x be the random variable, the number of calls that Jose receives per hour. H0 will be that lambda is equal to 5. On average, he receives 5 calls per hour. That's what he's supposed to do. And H1 will be lambda is more than H5, more than 5. Right, because we're looking for a definite increase here, this is a one-tailed test. So under H0, x is Poisson lambda 5, and we perform a one-tailed test. Calculating the test statistic, the probability that we want the probability x is greater or equal to 9, given that lambda is 5. Lambda is 5 under the null hypothesis. And that will be 1 minus the probability that x is less than or equal to 8. Right, we need some tables in order to do that. Now you can get the tables from a book or from the GeoGebra calculator. So you go into GeoGebra page and go into View and open up Probability Calculator, and then set lambda to 5. We want the continuous random variable, and we want less than 8, so we want 0.9319. Or you can get the tables from a book. So we need to do 1 minus 0.9319, which gives me 0.0681. Conclusion will be, well, as 0.0681 is bigger than 0.05, we do not reject H0, and we say there's no significant evidence at the 5% level that Jose is overworked. These are called p-values. This is a p-value. Okay, well, so this is 6.81%, and this is 5%. Now, if we use the probability calculator, so going back to that for 1 minute, and then deselecting the community part, and then we want to set this to more than 9. Again, notice we get there 0.0681. Okay, you probably wouldn't use this in an exam, but using it so you can get a visual idea what we're doing here. Here we have the distribution, and here we have 9. Now, if you work out what these are, in the 9th one here, in it will be 5% of the distribution, but we've got actually 6% of the distribution. Okay, so this bit here is where we reject H0, but we've got 6.81%, so that's more than that, and therefore we say we do not reject H0. This is how it works. Okay, so this has been a video to show you how to use an observed value to test an observed value of a Poisson distribution using tables. I hope you've understood, and I thank you very much for watching.